So in today's lesson, we're going to talk about how to properly draw the atomic structure of different elements in our periodic table. The two most common methods are the Bohr-Rutherford diagrams and the Lewis dot diagrams. And we're going to start off by talking about our Bohr-Rutherford diagrams. Now these diagrams show the number of neutrons and protons in the nucleus of an atom, and the electrons are arranged in what we call energy levels, or shells, or orbits. So those are the three terms that we use to describe the same thing. Now, there are rules with regards to how many electrons can be in each orbit or shell. So before I start drawing them, I'm going to give you those rules. So for the first shell, only 2 electrons, and this is going to be my short form for electrons because they're negatively charged. 2 electrons are in the first shell. In the second shell, it can hold up to a maximum, so these are maximum numbers, of 8 electrons, and in the third and fourth shell as well, those also can hold a maximum of. I want to show again that we're talking about the maximum number of electrons that can be held in each shell. So these are maximum numbers. Now, for the purposes of grade 9, we don't need to do anything beyond the fourth shell. Although, if you continue with chemistry in the later academic years, you will. But for the purposes of this class, we are going to stop at the fourth shell. So how do we draw a Bohr-Rutherford diagram? So the way we start is let's first maybe pick an element off our periodic table. Let's pick the element phosphorus. So what you need to do is you need to go to your periodic table and find where phosphorus is. And you'll see that it has an atomic number of 15, and an atomic mass, and this is just for reading it. Now, if you're on your periodic table, you're going to notice that it says 30.974. Now, what we're going to do for the purposes of calculating the amount of neutrons, we are going to round that. So 30.974 is rounded up to 31. Now, we remember in the previous lesson that the atomic number is referring to how many protons are in the nucleus of our atom. So in this case, right away, if I'm drawing the nucleus, I can say there are 15 protons in my nucleus. Well, how can I show how many neutrons there are? In the formula, we know that we can calculate the number of neutrons as the atomic mass minus the atomic number. And in this case, it is going to give us 16 neutrons. And we're going to put that in our nucleus. Okay, so we've completed the nucleus diagram now. Now we have to look at how many electrons our atom has. We know the rule that when atoms are neutral, that means that the number of protons has to equal the number of electrons. So if I know that I have 15 protons, that means I also know that I have to have 15 electrons. So the number of protons has to equal the number of electrons, which we got from the atomic number, which is 15. So now we have to arrange these 15 electrons in our shells or orbits or energy levels. These terms are going to be used interchangeably because they're all referring to the same thing. So we're going to draw our first shell, and that is what we draw as a circle around our nucleus. And we know that the rule says that our first shell can only hold 2 electrons. So those 2 electrons, I'm going to use blue to show my electrons so they can stand out. So that's how we show 1 electron and another electron. And we know that our first shell, that's it. We can't put any more because our first shell can only hold 2 electrons. Now, we have a total of 15 electrons and we've only placed 2, which means we still need to arrange 13 electrons in other shells. So we're going to draw our second shell. So we'll put it like that. Now, we know our second shell can hold 8 electrons. The way I like arranging my electrons is in clockwise order. And we also pair our electrons. So the first thing that we're going to do is we're going to start at the top, and I'm going to count 1, 2, 3, 4, and now I'm going to start pairing. 5, 6, 7, 8. So now I have paired my electrons, and they hold a maximum of 8 electrons in our second shell. So let's count. How many electrons do we have in total now? We have 8 in the second shell, 2 in the first shell, so that's 10. We still haven't housed all our electrons. There are 5 more electrons that we need to arrange in their shells. So we're going to draw one more shell. So this is shell number 3. And remember, I only have 5 more electrons that I need to place. So I'm going to start from the top. 1, 2, 3, 4, 5. And now I stop. Okay, so just because the third shell can hold a maximum of 8 doesn't mean it has to hold all 8. Here, our third shell only holds 5. So let's count our electrons in total to make sure we're correct. Shell number 1 has 2. Shell number 2 has 8, so that's 10. And shell number 3 has 5, so that's 15 electrons. So we have now drawn the Bohr-Rutherford diagram for the element phosphorus. And what's nice about Bohr-Rutherford is that it tells you how many protons and neutrons are in the nucleus, and it shows you how many electrons are in each shell. So just to make sure that you guys are familiar with it, this is the first shell. The second one here, that's the second shell. And this one was the third shell. So here we have the element phosphorus that has 3 shells. Now I want to draw your attention to the electrons that are in the last shell. And in our case over here, the third shell is our outermost or last shell. Now it could be different, right? I mean, if an atom has 5 shells, well, then the 5th one would be the last one. In this case, the third shell for phosphorus is the outer or last shell. There is a special term for the electrons that lie on the last shell. And that term is the valence electrons. And these are important, and you're going to see why as we move along. The valence electrons are the electrons in the outermost shell. Now, in the case of phosphorus, how many electrons are in the last or outermost shell? Well, there are 5. So phosphorus has 5 valence electrons. And like I said, this is a very important word and topic to understand, because really it is these valence electrons that determine the reactivity of an element. But right now, I just want you to understand what a valence electron is. Valence electrons are the electrons that are in the outermost or last shell of an element. Now in this case, phosphorus has 5 valence electrons. Let's try one more example together. Let's look at the element beryllium. Beryllium has the symbol Be, and if we look at the information that we have from the periodic table, it has an atomic number of 4, and it has an atomic mass of 9. So that gives us a lot of information that we need for our nucleus. So atomic number of 4 means that we know right away it's going to have 4 protons in the nucleus. How can we find the number of neutrons? Well, we know we can calculate the number of neutrons as the atomic mass minus the atomic number, and that gives us 5. So we're going to record that as 5 neutrons. What about electrons? Atoms are neutral, which means that if we have 4 protons, that means the number of protons equals the number of electrons, which is 4. So we now need to place 4 electrons in the appropriate energy shells. So we're going to draw our first energy shell. And that is going to hold, as we know the rule, 2 electrons. Okay, but we have 4 electrons. So there's 2 more that we need to place. So we have to draw another energy shell. And these 2, remember, we start clockwise before we start pairing them. So we go 1, 2, and that's it, because we have 4 electrons. Now, if I was going to ask you how many valence electrons does beryllium have, well, you're going to look at how many electrons it has in its last shell. And in this case, there are 2. So that means beryllium has 2 valence electrons. And I want to show you why this is actually a really cool about valence electrons. Is the number of valence electrons an element has is actually associated to the group in which the element is. So if you look at beryllium on the periodic table, you're going to see that beryllium is in group 2. And it has 2 valence electrons. And actually, if you were to draw the Bohr-Rutherford for all the elements in group 2, such as magnesium, calcium, strontium, barium, and radium, all of them are going to have 2 valence electrons. So you'll see a trend here. If you were to do the Bohr-Rutherford diagrams of all the elements in group 1, they would all have 1 valence electron. And that continues as you go along. Group 3 elements are going to have 3 valence electrons. Group 4 elements have 4 valence electrons. So it's a great way of remembering, instead of having to draw the entire Bohr-Rutherford diagram, if you can find what group an element lies in, you will automatically know how many valence electrons it has. So if we look at example nitrogen, so I don't even want you to do the Bohr-Rutherford for it. If you go to nitrogen and look for it in the periodic table, you will see that it exists in group 5. So this is just reading it off the periodic table. And that automatically tells you that nitrogen has 5 valence electrons. You don't even have to draw it. The way the periodic table is designed is that each group contains the same number of valence electrons. So the elements that are with nitrogen in group 5 are phosphorus, arsenic, and so on. They will all have 5 valence electrons. So I love patterns, and I love the way that this is also a trick to remember, or to be able to determine how many valence electrons an element has just by looking at the periodic table.